Hello and welcome everybody. Good morning, good evening, good afternoon from Munich in Germany and from Tom in Raleigh.
Raleigh, North Carolina.
Raleigh.
Yeah.
Sorry, I was just stumbling over my own tongue apparently. And yeah, thanks for joining. Thanks for joining everybody live in chat. Hope you have a good day. Your Tuesday was good or is good, is going to be good, depending on what time it is for you now. And yeah, thank you for joining. Thank you, Tom, for making the time. This time around, we are looking much better. So I don't know if you watched this. Or I tried to watch it, I guess, 2 weeks ago, where we had technical issues and for some reason couldn't really get the stream working and had to postpone. So this is basically catch up time. But yeah, it was it's going to go well today. I'm confident. um, cool. So yeah, I wanted before we dive in, I wanted to do and I guess I do this for the very last time about the call for papers for notes. So here it goes. It is open till tomorrow, 31st of August, end of day UTC 23 p.m. 11 p.m. UTC. So at the end of the day, tomorrow for most of us. So if you're thinking about submitting, this is now your final reminder, I guess, from me and your almost last chance to submit something. So do it now. Don't delay any further, I guess, because this is the final call, and this will then close, and then you won't have the chance to submit. And you will miss out on being part of a great event, at least as a speaker. Obviously, from next time I'm streaming again, I'll talk about registration. So I guess the story is not over. But if you want to submit as a speaker, want to be part of it, could be a lightning talk, could be a workshop, could be a full session. Please do so now. Otherwise, it's going to be too late. Okay. I think I covered that. I think everybody is aware now. Let's talk about the topic of today. So Graphyx, the Alteryx connector for Neo4j. Maybe before we do that, Tom, maybe you want to say a few words about yourself, who you are, what you're doing. Yeah.
Sure. Yeah, definitely happy to. My name is Tom Larsen. I work for a company called ABB. Most of you in Europe know who ABB is. Most of you in the US and Americas probably don't have as much familiarity with ABB. We're a large B2B company, have a couple of major businesses around electrification products, robots, industrial control systems, any kind of industrial automation type process. ABB is involved in producing solutions for that. I've been with ABB I'm coming up on my 5-year anniversary now, so it's been a little while.
Congratulations.
And yeah, thank you. It's been quite a journey. And my current role in ABB is I'm a senior manager of our forensic analytics department, which for me is a relatively new role. I started in this role beginning of last year, and was a shift from where I was before, which was the internal audit department, focused mainly on audit specific analytics. So that's where I've been for most of my career, ever since I started my career about 12 years ago. It's really been focused on the internal audit side of the world, and in particular looking at data analytics from an audit perspective to do full population testing as opposed to more traditional sampling-based methods. And we're trying to take that mindset and apply it to a forensics investigations department and see where it goes.
Cool. And nice. Sounds very exciting. Before we dive, because I'm interested, forensics meaning you talk about products that broke down, or forensics in terms of investigating. I don't know. I think I only connect this with crime, but I guess I don't know if that is the right way of connecting it.
Yeah. So my day-to-day, my primary stakeholders are the legal and integrity department. So forensics from an integrity / white collar crime perspective, primarily, where we're trying to proactively identify and reduce the the incidence of things like embezzlement or bribery or
Okay.
other things that we really don't want our people doing or engaging in those kind of behaviors. And my team is quite a talented team with a wide variety of experience from a forensic data analytics firm. I have a guy from there. I have a guy who was an investigator for many years, and then there's a couple of us who come from the internal audit side. So a lot of a lot of knowledge about data analytics. A couple of us have a lot of experience with SAP, and ABB is an SAP shop. And so what we're really trying to do is to work with the investigators on their investigations to help them get a sense of the data behind the investigations that they are working on at the moment.
Mhm.
And then as another major work stream, we're also looking to do an ongoing monitoring platform where we want to proactively identify things before they get big, before they become a major issue for the company, and also to signal to the rest of the company that these behaviors are not okay and that there's someone out there taking a look at it.
Okay, that's very very interesting, very exciting. Cool. And then you at some point, I guess, I mean, otherwise you wouldn't be here. You discovered graphs and Neo4j. How did that go? How what was your first impression, or how was your connection? I mean, I guess forensics or investigative, working with data investigatively is kind of like a natural fit, since, and everybody knows this, I guess, since a couple of years ago the ICIJ leaked, or used a couple of leaks to drive investigations on Panama Papers, Paradise Papers, Swiss leaks. I don't know what else I missed now, but yeah. So I guess the connection is there, maybe, but or is it coming from somewhere else?
So the journey is an interesting one. I had heard about Neo4j at some point, and graph databases in general at some point a couple years ago. I'm always looking for new tools, new platforms that can make my job both easier and let me sleep better at night. Because while the job is quite interesting, it also keeps you up at night. Um,
Yeah.
and so I had heard at some point about graph databases, and it's like, oh, that's really interesting. I'd really like to try that someday, but I really have no like place to start. I have no foundation to work off of. My entire career, I've been working with databases and with tables and table structured data. So, with when you're knee deep in SAP, like I am, getting down to tables and trying to figure out how SAP works, there's not a lot of mental capacity left over for new ideas like a graph database. And so I kind of put in the back of my head, I want to revisit this. Maybe now's not the time, but we'll take a look. And then when we
Mhm.
started this department at the beginning of last year, one of the guys I hired, his name's Alex Orban, had some experience and some hands-on application of Neo4j and graph databases.
Oh, okay.
And thought, well, this is fantastic. I've been interested for a little while. You have some experience. You can maybe help accelerate the learning curve here, so I don't spend weeks doing something that's just stupid. And so he and I sat down and came up with a pilot, a proof of concept that would be something relatively small, relatively easy for us to get our hands around, to try out graph databases. And he came up with a schema for us, and I'll show you a couple of things about the schema we came up with and how we use it on a day-to-day. But he really helped put in that initial work to kind of level us up to
Yeah.
even try our first pilot.
Okay.
Which kind of brings us to Graphyx, because my role in this team, while I am the senior manager, I do most of my work in the background and let my team, who I think are analytically a lot more clever than I am, I let them, kind of try to enable them to do their work better. So I'm building a lot of the infrastructure behind the scenes, which the rest of the team will use to be faster and to be better at their jobs. And one
Okay.
of my requirements for bringing on a new tool is it has to integrate into what we have today. I can't just have this tool sitting over here. It's really hard to get data into, really hard to get data out of. that's its own
Yeah,
thing that will
you
eventually
create
just
your own silos, and then you know what's the point? Nobody will use it. Everybody will struggle with it. It's gonna be basically a dead dead end, and yeah.
it, exactly. And so as I was looking at Neo4j, I'm like, how can I integrate with this thing? And I'm sort of a aspire to be a programmer someday. And I know the Go programming language, and what really intrigued me is Neo4j has drivers for the Go programming language. And a couple years ago, I had actually built an SDK for Alteryx for the Go programming language. Alteryx, its engine has a C API, so you can build new functionality for Alteryx by leveraging this C API. And so I built an SDK on top of that would do all the plumbing to go from C to Go, so that I could build new functionality in Go for Alteryx. And so, I got Alteryx and with Go, and I got Neo4j with Go. Boom, perfect match. And so Graphyx was born out of that, a way to seamlessly integrate Neo4j, this new really cool tool we want to try out, into our very established infrastructure and architecture that is primarily driven by SQL databases and middleware tools such as Alteryx.
Mm-hmm. Very exciting.
Yeah.
Yeah. So because I don't know how many Alteryx users there are, and I guess you are using it a lot, so it doesn't make sense if I explain it a lot. Maybe you can spend a few sentences on what is Alteryx for the people who don't know it, and what is it, why are you using it, and what are you using it for? Maybe so just a quick
Sure.
intro.
Yeah. So Alteryx is a data analytics platform. Um, it's for us, its bread and butter is your typical ETL or data munging type scenarios where we have to join data from disparate systems, disparate files, to create a data product. It also has artificial intelligence, predictive modeling, other kinds of advanced analytics tools, which quite frankly is beyond my mental capacity. So I don't really do much with that. But as a data munging tool, it's wonderful. It's beautiful. It's all visual. It's a low code / no code tool where you drag and drop icons to do the data transformations. It handles all your basic data transformations, from joins to aggregations to cross tabulations or transpositions, add calculated fields, filtering, all the stuff you could want to do with data. You can do it with Alteryx. And it reads and writes to many, many, many different data storage mechanisms, whether it's a database or a flat file or elsewhere. So for us, we use it. We have a data replication tool. It's called Click Replicate, or it's replicate by click. That is real time, near real time, extracting change log information from our SAP instances, and it's applying those change logs to SQL Server databases that we can access. So we're kind of building a near real-time warehouse off of using this Click Replicate from our SAP infrastructure. And I'm not involved in any of this. There's some really smart guys handling that process, and kind of a sister team of ours. And so we use Alteryx to transform all of that raw, clunky, terrible SAP data into something that we can use on an ongoing basis. We munge tables together to create what we call views, and these views might be a view of purchase documents or invoices or sales orders, where instead of everyone on my team having to have a really deep knowledge of SAP and all the little clunky edge cases where things are just goofy in SAP, I do a lot of the work to prepare these standard views so that they get a data set that they can just jump right into and begin doing their investigative process. And we use Alteryx for that entire munging process. Basically, anywhere we got to go from data here to data here, Alteryx is that plumbing for us.
Very nice. Okay. Cool. I think that's great. That explains it. Yeah, and I think we can let's continue, and I think we can go in to you showcasing Graphyx a little bit, before you do that, I wanted to say again, open the invitation to chat. I mean, if you have any question, any comments, any feedback during the presentation, please don't hesitate and type it in chat. We would like to keep this interactive as possible. So if you see something you would like to know more about, if you don't understand something, or if you have a comment on anything, I'm here to relate questions and comments to Tom, and then we can discuss a few things. So please don't be shy. I don't think this is a webinar or something. This is supposed to be interactive. Yeah.
Definitely, and open invite to you, Alexander, to interrupt me at any point. As you notice, I might occasionally go on, so feel free to just stop me dead in my tracks if a question
All
comes
right.
in.
Yeah, no worries. I'll do that, and if I have any questions, I'll obviously take the chance to ask them. But if anybody from chat wants to chime in as well, then please do so.
Cool. Then I'm going to go ahead and pop over to my screen. Hopefully, I've done this right and you can see it.
Yeah. Get this out of the way and zoom in a little bit here. This should be fine. Yep.
Cool. So part of the reason that 2 weeks ago didn't work out so well is because I was trying to join from my work laptop to make some of this a little more dynamic and like real. So I'm joining from a personal laptop of mine. And so some of this stuff, particularly around what we're doing with the graph database, is going to be a couple of PowerPoint slides. Apologies for that. But it should give you an idea of how we're using the graph database. And that will help, I think, to understand as we go into the Graphyx tools, how those are helping us to achieve this pilot and how it's going to help us to achieve our future goals here. This is our schema that we came up with the pilot. And what this pilot really is a data discovery pilot. ABB not only is an SAP shop, we like to collect SAPs, and we have like between 30 and 40 different SAP systems around the world. It's a huge number, and it's a really complicated landscape. And one of the hardest things to do, strangely enough, is to know where subjects of investigations are. What system are they interacting in? And so we built this pilot as a way to significantly shortcut the data discovery. And the way that this works is an investigator will come to us through an email or through a chat, and they'll say, we got this allegation. This is the subject of the allegation. Usually a name, maybe an address or a phone number if we're lucky, but usually just a name. And they'll say, can you help us substantiate? Can you see this pattern of behavior in the system? Is there anything in the system that would suggest that this is actually happening? And so, for most people, it's like, okay, yeah, we'll go look up their account and we'll pull their transactions and boom, we're done. But, when you have 30 some SAP systems where they could potentially be in, it's not just as simple as boom, we're done. And so we basically take all of these SAP systems and we dump them into Neo4j in this schema. And the schema is really designed to identify vendors and customers from SAP. And so those are our primary nodes. That's why I've made them bigger here. That's really what we're trying to get to. And connecting vendors and customers to each other and to each other are different attributes of that vendor or customer master, such as a phone number or an email or an address, name, bank account, tax information. This little GUID thing is an internal ID. It's supposed to be a global identifier so that it's the same GUID in every system that business partner might be in, to greater or lesser success depending on I guess who did the initial onboarding.
Yeah.
So this is the schema that we have created. And because all 30 some systems are in here, we can write one cypher query and we're instantly querying across the entire landscape that we know about and that we have access to, and finding connections across that landscape. So we don't have to then, go into different systems to find these connections. It's all one place. A couple of quick examples. I've anonymized everything. Basically, what you see is the internal ID of all these nodes. So we're not going to leak any data and make me lose my job here.
Please don't.
So these are a couple of examples of results that we've gotten from actual investigations where we've looked for a name and tried to find where they are in the in our systems. And on this result here, it's kind of interesting. On the left side, we have, was it 3 different customer accounts and then 1 vendor account, which all share the same name. And the interesting thing is that these are from 3 different systems. I have this arrow in the wrong place. It should be here is system B. And so we have 4 different business partners from 3 different systems, all linked by the same name, which we wouldn't have been able to identify if we just took this system by system. It would have been really time intensive to do that. And then now, because we've made these connections and we've structured the query in a certain way, we can also see all of the other different attributes and what attributes they share. For example, these entities share the same global identifier, whereas these over here share the same address. And so we can see not only are they connected by name, what else are they connected by?
Mhm.
And then we had a second result here, which again is connected by name and connected by another global identifier. And this was a separate cluster. That this was part of the same query return, but there were 2 separate clusters. And what's interesting, going back to that comment about the global identifier, is that we have like 1, 2, 3, 4 different global identifiers in this data, and they're not. There's not one global identifier that's linking all these entities together, and they are the same entity. And so this is allowing us to really quickly not only identify the business partners that we are looking into, but it's also going back to that being able to sleep at night thing. I feel a lot better that our data discovery process is robust and we're capturing what we need to be capturing. We're not missing an ID in the system that could make or break our analytic downstream.
So in this case, it doesn't. I mean, obviously, it would have been better if all of these would have the same global identifier, because it in fact is the same company, but because of the linkage and because of the enriched data you had through the graph, you were able to identify, okay, actually, in fact, these are the same companies, even though they didn't have the same global identifier, which made it possible to find them, basically. Is that, yeah.
Definitely, yeah, yeah. Exactly. And this is ABB is my 3rd major company I've worked for. Every company has master data quality issues. Okay, there's no way around it. When you have a bunch of different people entering master data into one or more systems, you're always going to have these issues. And so you can't make assumptions that the global identifier is robust. You kind of need to prove it out yourself or disprove it, as the case may be. So for us, the global identifier is not a be-all, end-all. It is another way that we can link potentially related entities together, so we get the full subject population of IDs in our systems. One other example, which I like here, was another query that we ran. And I apologize, the node colors are all different on this one. Where we did a name search and we got part of the graph, probably this one down here. But then as we go out further away, we identify 2 other related entities, but they're not connected by name. They actually have a different name. They're connected by fax numbers, and this one's also connected by an email address. And so this is something that, to do this manually would just be an absolute nightmare. We'd have to pull the 2 that we know the name for, and then go into every system and look at the individual values to see if we can make that connection manually. And no one's going to do that. It's just too much work, too much effort, and too prone to error. Even if we did do that, we'd likely make a mistake somewhere. And so what we really like is this gives us the ability to start with a name match, but then see where that graph takes us and pull in any possible related entity in one relatively simple cypher query. And so again, I sleep pretty well at night knowing that we have this capability in-house. So that's our pilot. That's our use case. All the people on my team use Neo4j now. When an investigation comes in, that's our first go-to, is let's find these people, and that's our starting point. And it went from pilot to like production super fast. You know, the first couple times we did this, we're like, yeah, we can't get rid of this.
That's good to hear. No, but that's one of the major, I think, advantages of a graph, of the and it comes together with the visualization, right? I mean, if you are, your team doesn't have to be Neo4j or graph experts. They can just they get the queries, they have some kind of tool where they can look at it, and then they see the connection, and then they see, okay, understanding, okay, yeah, here we have this same entity connected by name, by phone number, or by some other data, even though their supposedly unique IDs are different, and it makes it very, very, very easy, and it's very quick. So yeah, I think that's great to see, and yeah, it's cool, and it's always, it's always funny, that you, at least from me as a sort of outstanding person, see, okay, why how does it come to that? Why do all these entities have different identifiers? They should be the same. When you think about it, that when you enter the data, yeah, you connect it with an existing system, but then again, uh, obviously you make errors. It could be just a typing error, that you mix up numbers, but it could also be that, different system, different people, they were not aligned, and you thought, okay, this is not existing, and then you add it again, and then it makes an error here and there, and then it makes it very hard, like you said. I mean, if nobody wants to crawl manually through dozens of systems and data sets to find if there is a linkage or no, or if there's a connection, and then you make the same errors again. So this is, yes, good.
Yeah, and going back to your comment about the visualization, I really like this part of Neo4j. I know you guys are moving away from kind of like the graph database messaging to like graph platform, analytics platform, but having a database that gives you this kind of querying and visual, like this feedback, is absolutely amazing. You know, when you're coming from something like SQL Server Management Studio, you type in a query, you get a table of data back. Okay, now you got to do a bunch more with it to actually extract out the value. And I really like coming in here, and the visual that you get back just has so much more to it. It just feels so much more comfortable, so much more natural to explore your data and see where it goes than using more table driven tool sets. It's a really nice thing. I couldn't imagine Neo4j having half the value if it didn't have this out of the box, this ability to visualize the graph as part of its just core product. Really, really happy with that.
Yeah, I agree. I think that is the big advantage, totally, with browser, and or with Bloom as well. If you go further and you want to have a little bit more capabilities in the visualization aspect, but yes, absolutely. And I think that this, most of the people, happens what you just described, right? They write a query and they don't think much about it, but then they expect a table or some boring field to get back, and then have to work on that again. But then here you write your query, and then you click on, let's say, give me a couple of nodes, and then you actually see, okay, here are some nodes, and I can even explore the data on the fly inside my browser window. I don't necessarily have to write any queries. I can just click, oh yeah, let's show me all the neighbors, expand, 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 and then I follow the path, and it's like, um, it's fun, but it's also very interesting, and you learn things, and you explore your data this way, which makes it more easy, and more productive.
Absolutely. Yeah, absolutely. Great platform. Um, so that's our pilot. That's where we're at today. That's what we're using. So now that I've kind of set the stage, I'd like to introduce the tools that I built to connect Alteryx into it, and then show you our refresh process, what that looks like in Alteryx, so you can kind of see how we're getting the data into Neo4j, and then eventually out of it as well, if we so choose. Um, how's that sound?
Sounds very good. Yes.
Okay, so there's three primary tools that I built for Alteryx, and call them Graphyx. I guess I was being clever that day. Graph, YX is an Alteryx thing. Put it together, you got Graphyx. It sounds like you're doing some low level game programming, but totally not that at all. So we have a standard input tool, which we'll go into. It's probably the most complicated of the three tools. We have an output tool, which is like my favorite because it's that integration for us. And then we actually have a delete tool. One of the things that a lot of integrations don't think about is removing your data when
Hmm.
it needs to be removed. Like if a business partner changes their address or changes their name, I mean, you kind of need to delete the old one to put in the new one, so you don't have two of these relationships now, one of them pointing to an old name. And it's actually kind of hard to do in any kind of like database management system. The connections in Alteryx, not really like a delete tool. So I put in a delete tool. Now, funny, now that I've said all that, I actually don't use the delete tool yet, but it's there for when I'm
Good to
ready
have.
for
Yeah.
it. We have it.
Yeah.
And so the first one I want to start with is the Neo4j Output tool, because this is what takes data from an Alteryx data stream and pushes it to Neo4j. And we use this every month when we run our refreshes. So, full disclosure, we do a monthly refresh. It's not real time. The marginal, like the amount of effort to get that marginal benefit for my relatively small team, just it really doesn't make a difference. So
Okay.
we'll pick other low hanging fruit, and then when we need that real time, we'll worry about that later. So we use this output tool, and what I want to kind of do is I have Neo4j desktop up and running here. It's the movie database with a couple of garbage nodes thrown in
Hmm.
from who knows how long ago. And what I want to do is I just have a very simple table here that gives me just a very basic set of relationships. Node 1 is connected to node 2 is connected to node 3. And what we're going to do here is on the top, we're going to export the nodes. And on the bottom, we're going to export the relationships. So they are two different operations. And basically what we're going to do here is we have this ID field. This is what just ends up happening. Very basic. We're just literally just creating nodes with an ID property. That's nothing too special there.
Hmm.
And so what the Graphyx tool is you have your connection information. We're going to just expand that back up. And the next part of the Graphyx of the output tool is to then specify things like the batch size. 10,000 is the default. I find that's a nice middle ground to use,
Hmm.
but you can change it if your needs require. And then you specify whether you're outputting a node or a relationship. And then what you're doing, because we picked node, you're specifying the label for that node. So I'm going to give it a wonderfully descriptive label. We're going to tell my future self to delete this. And then we're going to tell it to update based on the ID field. And what this ends up being is an upsert operation. If that ID field, if a node with that ID already exists, it's going to go and it's going to update that with the new values from the properties, and you can specify property fields to update. If that node doesn't exist, it will create a node with that ID field property and then add in all of its other properties here as well. So one of my biggest annoyances with connecting and exporting data to something like SQL Server doesn't really have a good upsert process built in. But Neo4j actually makes it really easy, and coding this in the background to do that upsert, so that you don't have to worry about losing data integrity because you miscoded the cipher for it. That's the output tool. It's quite basic. You just specify um, your ID fields, and again, these are typically properties that you're matching against. And so, tip is to use a constraint on these nodes when we're updating our master data or data discovery pilots. We have a constraint on one property field in each node type that we have, so that the upsert is super fast. If you don't have that constraint and you're updating like a million nodes, it's going to take a while. That constraint makes it blazing fast. If you don't provide an ID field, it's just going to dump the table into the database without doing any kind of checking. It's literally just throwing the data into the database. So
I see.
it's
Mm.
basically just a straight insert. There's no upsert involved in it.
Mm-hmm. But I guess if you have already existing data, you should not not do that, because that will create duplicated data, and then you have yet another mess in your graph instead of in
Ex-
your, say, SQL tables.
Exactly. Exactly. And that's why I baked the upsert into the output tool, because I didn't want to have to do a bunch of like stuff in Alteryx to get me the list of nodes I'm actually uploading. Like I just want to throw everything into Neo4j and let the constraint and the upsert figure it all out for me. So
Mm-hmm.
it makes our ETL workflow a lot simpler, which is good for me, because my active memory is rather limited. So that's the node export. You have to export the nodes before you export the relationship, so the nodes are there. If you try to export a relationship and one of your nodes isn't there, the relationship won't get created. So I have this set up so that it will always do the nodes first, and then you come down here, and same kind of process. The major difference here is we're specifying a relationship export, and we're giving that relationship a label, another wonderfully creative label. This is something I relatively recently added. You can specify ID fields for relationships as well. So if you want to update a relationship, you can, or if you don't specify it, it's just going to upload the relationship as an insert and it won't do any kind of updating. You can specify properties for the relationship and it will add those as well. And then you specify how that relationship gets linked from the data. So you're specifying the left node label that you're matching against and the ID field. So in this example, we're starting with from, and it's going to map to that node's ID property. And then we're specifying it's going to be the same node label on the right-hand side, the delete label. And again, we're using the to field, and it's going to match that to field against the ID property of the delete node, and it's going to create that relationship when it finds a left and right match between them.
Mm-hmm.
And so if we do a quick run here, it should be quite fast. And we go into Neo4j desktop. I should have a new delete node type, and we've created our little graph here, super high value graph.
Yes. That's cool.
So
That's quick and easy, and works quite well. The relation, or the way you do it is I think the standard Neo4j requirement. So you cannot have a relationship without two nodes. So a relationship always has to go from one node to another. They cannot go. They cannot exist with only one node or zero nodes, or there cannot be lonely relationships. It always has to be a connection between two nodes.
yeah, exactly. One of the things that can be a little bit limiting, which I recognize in these output tools, is the node label is a fixed static value.
Mm-hmm.
You can't specify a field in the data and say use this field as my label. And actually, the reason for that is well, to be perfectly honest, because it was easier to code it in the background. But we're just going to pretend I didn't say that. Um, there's the real reason for that is kind of one of performance, that the query, the update query is optimized if you're only specifying a static label. Otherwise, you have to create as many Cypher queries as there are labels, right? Labels can't be parameterized in a Cypher query. And so this helps to keep the output tool high performance, and maybe makes you be a little more considerate of your data and your ETL workflow, which is I need that kind of discipline in my life. So I find it helps to be a little more deliberate about how I set up these ETLs.
Yeah, makes
Okay,
sense. Mm.
so that's the output tool. I can move on to the delete tool if there's no questions.
Joy just asks, is there a specific Alteryx version needed to get this connector? I don't see it available in the connectors category or in help. How do I get this?
Yeah, okay. So I'll skip ahead to that real quick, and then I'll probably reiterate it at the end. So this is not something that comes with Alteryx, and Alteryx does not provide any warranty for it. It's purely mine. And so there is, and it's all open source. I have the code and everything on GitHub, and I imagine we'll provide these links.
Yes,
which
I'll post the
gives
link in.
you perfect. Yeah, it'll give you some idea of how they work. There's a nice little README. I put a lot of work into this README for GitHub, so feel free to read it. And then that's not uber user friendly. I do have a website set up. It's based on Gumroad. If you've ever heard of it, it's an online store basically, where you can actually download an installer and it will install it for you. Put all the files where it needs to go. Because it's an online store, it says name a fair price. The intention here is you put in 0 and you click I want this and you get it for free. I'm not looking to make money off of this. It's just there so I can track usage a little bit, kind of know how popular it is or how unpopular it is, whatever the case may be. So this would be your best bet for obtaining that installer to install it. Once the installer is finished, you will then see these 3 icons pop up in your connectors tab in Alteryx. You may have to restart Alteryx to see them if you had it running when you did the installer, but it'll be there at some point.
Okay. This should be fairly straightforward. I'll post the link to GitHub as well as to the direct installer downloads in chat. And I'll
Cool.
put them in the video description as well. So for anybody that watches this afterwards, you can find the links in the description.
Perfect. Thank you. Okay, so the delete tool is, again, similar user interface. So it should be somewhat familiar here. You specify the connection details, blah, blah, that's boring. You got the batch size, you got the type of object you're deleting, and then in this case, we're going to delete those 3 nodes I created. So you're specifying, again, a static label, and you're specifying the ID fields that you want to match to determine what you delete. And so we're going to match the ID field coming in. You see those same IDs that we had before, 1, 2, and 3. And it's going to basically go through and ingest that and send delete commands to get rid of everything that matches those. This is a detached delete, so you don't need to worry about purging the relationships first. It's if you tell it to delete a node, it's going to delete all the relationships for that node as well. So you don't have to worry about getting the relationships out of there first. Because again, that's more work than I wanted to think about. And so we run it, and we should see that this query now, those have been purged. All 3 of those nodes are gone, and that's how you delete records. One thing I have in my mind, because I actually find the delete tool to be a little bit not really fit for the purpose that I originally intended it for. In that, deleting those old relationships when you're doing a full reload is actually rather difficult to identify. You kind of have to bring in all the relationships and join it against your new relationships, and then use a delete tool to delete off the unmatched ones. It's just a lot of work. One of the things I have in my mind here is to provide an option where if you're doing an output to a node, you can tell it to delete the existing node before it does the upsert. And then it will basically purge out all those relationships. So that's kind of in the back of my mind that, there's certain nodes, like if we come back to this schema, if I'm uploading a vendor, I just want to purge all those relationships. I'll build them back myself. So just delete, detach that vendor node, and then upload a new vendor node. And then the second pass, the relationships will come through, and I'll get the new ones added. So something I'm considering as an enhancement to the output tool.
Yeah.
Okay.
I guess it makes sense if you're directly uploading new data that replaces old data, and you don't need to keep the old stuff around. You can just wipe it and put up the new one.
Exactly. Yep. So this is the Alteryx workflow that actually does our refresh process. It's 3 main steps. These are called macros. They encapsulate a bunch of logic into one little tool. Quite nice little feature. And it's a 3-step process. 1, we pull in a bunch of SAP data from raw SAP tables, and we clean it up. So you're going to see tables that if you've worked with SAP, you recognize. KNA1 is the customer master. LFA1 is the customer master. The vendor master. These tables are for things like phones, faxes, and email addresses. That's our lovely internal ID. And so we're bringing in all these raw tables. We're doing some basic cleanup, like we're converting to lowercase, removing punctuation, just really basic data transformations. And then we're spitting them out into intermediate temporary files. And that's step one. Step two now, once we've done that for every single one of the systems that we're connected to, is we pull all of those data files back in. So again, here's LFA1, KNA1, all these other tables that have now been cleaned. And you can see that we're doing some basic processing to put some of the data together. And then there's the output tool. So our vendor node, for example, is taking pretty much everything. It's only coming from the LFA1 table. And we have a bunch of different fields that we're bringing in for that. And there's the output tool for it, where we're using a key, which is a concatenation of the database it came from and the vendor ID. So it's a globally unique key. And then we have a couple of properties that we're uploading for that node: the name, the vendor code, the posting block, and the database it came from. And so this is very similar to what I've showed you. Just, it's a real life example. This is actually the thing we run every month to update our pilot database. For some nodes, like name actually lives in 2 or 3 or 4 different tables. And let me make this a little bit smaller. And so we're grabbing all the different name fields. Fun fact, SAP, vendor master has 4 different name fields, and so does the customer master. And so we're taking all of those fields and we're putting them into one big table that is literally just one field with the value, with the name of name. And then we're pushing that into the output tool for name, where we're updating, we're basing it on the value. So nodes have a constraint on the value. There can only be one name node with that value. And so we do that for all the different node types. Getting lost here. And the final process is then to do the relationships, ingesting the same tables. Each of these tables has that link already inherent to it, right? The vendor code and the name both live in LFA1. So we just push that into an output tool that has, for names, is named. And we start with the vendor node. We match the key, and we have the name node, and we match the value, and then it creates that relationship. And we do that for all the different node types that we have, linking the vendors to their attributes, and then linking the customers to their attributes. And that is our ETL process. It runs, I want to say, for the 30 some systems we have, it runs in like an hour, which is remarkably fast for us to do this. And we could refresh this daily if we really wanted to.
Yes.
And not break a sweat.
Yeah.
Okay. The final tool, the input tool. And so what I kind of want to do here is I kind of want to play a little bit what we kind of do from an investigative side. I'm going to use the movies database because that's what I have here for you. And so what we might start with, right, is we'll start in the browser. We have kind of just want to start with, sorry, I want all the person nodes where, let's say I looked through this database earlier and I'm like, what actor do I actually recognize the name for? And Ron Howard, I know that name. Andy Griffith Show, right? I think that's right. And so we start with a basic search query. Oh, we found Ron Howard. That's fantastic. Okay. Well, now I want all of the movies that Ron Howard is in. So, might do something like this. I'm going to move. Yeah, great. It's my naming conventions here are a bit off. Okay, so here we go. We have all the movies that Ron Howard was in. Now I want all of the people who are also associated with these movies. And so while this is a very simple, contrived example, this is very similar to maybe the process that we use when we're looking for subjects of investigations. Except, I'll use like wildcards so that it'll go through an arbitrary number of levels, right? Maybe I'll put in a star, I'll tell it to go 2 to 4 levels down, something like that. Doesn't really matter here. But at the end of the day, we get a query that we like, and this is a nice query. Now, sometimes you need to get this back out into a tabular format. And this is really challenging because one of Neo4j's beauties is that it's schemaless. But schemaless doesn't translate to tabular super well. So so the challenge is to find a way to make that happen. And this is what I came up with for the input tool. So I'm going to copy this little query here,
Mhm.
and I'm going to throw it into, not that input tool. That was just in case I mess this up and can't recover. You're going to see how awful my typing is. And we're going to paste a query in there, and I'm going to validate that query. And it's going to run basically like a limit 1. It's going to add limit 1 to it so that it doesn't take forever on a large
Yeah.
database.
Yeah.
So we got that, but I kind of want a couple more things here. I want this relationship as well, and I want this other node as well. And we're going to return the path. We're going to return Ron Howard. We're going to return the movie, the relationship, and the other. And let's just return that. Validate it. And now we can start adding our fields. And this is where you take each of these different pieces that can be returned and you can turn them into fields in your data. So for the path, I'm probably just going to start with something as simple as just convert it to a string representation. I really don't need anything out of it, but there are other things you can do, like pick through a list of relationships if you really want to, a couple different operators for that. But we're just going to keep it simple here. I'm going to start with a name. This is going to be the Ron Howard node where we want to pull out the name property. It is a string value. And we just we tell the tool how to go down the tree of results to pick out these values. The movie, we're going to pick out a movie node. Let's do something where it's the title. Again, it's a string. This process is a little clunky. I have some ideas to make it better, but we're getting there. Got the relationship, and I want the type of that relationship. And then for this last one, we're just going to pull in the node. And again, we're just going to convert it to a string. Just keep it simple here. And that's our input tool. And then when we run this, we should get that exact same query that we had, but now it is in a nice tabular format. I can join it up against other tabular data. And if we need to incorporate into some scoring methodology that we have already built into Alteryx, is where we primarily use this, right? We bring in some of these relationships that we think are of interest, and we add that relationship data to other scoring methodologies to help us identify high-risk vendors or high-risk customers in our monitoring platform. And so this is how we get the data back out of Neo4j to enrich our monitoring platform. We build the cypher query that gives us the relationships that we're really interested in. We pull it into Alteryx, and we can enrich it with the other Alteryx data, and then it ends up in Tableau somewhere.
Okay. So you have a tabular data, and like you just said, you split it up, and then what you're interested in this case, just maybe the movie or a name or something like that, and you can use that, and then you use that data to put it back into your existing systems and forward it on. So okay, makes sense.
Yeah,
That's cool.
exactly.
Yeah.
One of the things that I really like about these tools is they allow us to get kind of Neo4j's foot in the door, right? Long term, I might like to do more, a lot more. Maybe our entire monitoring platform run on Neo4j. But to go from where we are today, where we already have a lot of investment, it's working, and we like what we have, to just like clean sheet it and rebuild, it's going to take forever. Um, and we will be without that capability if we just clean sheet it. Whereas this allows us to sort of inch our way to
You
a
add,
Neo4j future.
and you add. Yeah, I mean, this is great. I mean, you add capabilities you otherwise would not have to a tool that works well for you and that is well integrated, and you can add additional information, additional knowledge, basically derived from the graph into your scoring or into your mechanism, and by that, I think that's a great add-on use case. You don't necessarily have to clean sheet everything if the tool works for you. I mean, if you see problems, right? I mean, I would be the last person, obviously, coming from Neo4j to say, well, you should obviously base it on Neo4j. But if it works that way, I think that's a great add-on.
Yeah, and a lot of what we have is there because that's where our journey's been.
Mm.
And the pivot to Neo4j is not something that happens overnight, especially when you have an established
No.
infrastructure.
Yeah.
And so this allows us to do that journey, and I'd like to go on that journey. I'd like to do more. I do think that we can get Neo4j to a point as we look forward to the future. We want to bring in transactional data. Right now I'm kind of, when we have this list of codes here, we collect those IDs and then we do a search for transactions, and we do that back in Alteryx, or we do it in Tableau, or we do it in the source systems. I want to dump all the transactional data in the Neo4j so that I can say, okay, I had this query that gives me these customers and vendors. Give me all the activity for them. I want to look at their purchase orders. I
Oh,
want
yeah.
to pivot this way and that way, and I want it to be a single stop for me to go and be able to answer all these questions. And I want to be able to do it in a way that I can give this to an investigator who doesn't have my technical background, and they can do their own queries, and they can be a little more self-supporting. So that's like the long-term vision of where we want to go is to make Neo4j our self-service forensic analytics platform that the investigators can leverage and make use of without having to maybe wait on us, because every now and then we get overloaded. There's a bottleneck, and they might have to
Yeah,
wait a little bit longer than they want.
absolutely. Yeah, that makes lots of sense. That's cool. Yeah, I'm looking forward to seeing how that journey goes. But yeah, that's great. A question from Brian came just in. Does this work with Neo4j desktop? Yes, I guess we saw that in server. Would this also work with Aura? So basically, the question is, what credentials can you type into the connector,
Yeah.
and which other Neo4j deployments can you connect to when you don't, let's say, you don't deploy on desktop, you have Aura instance, or you have a server running somewhere.
Yeah, so I do have my own Aura account. I would pull it up if I knew where things were, but you don't want to watch me do that. That
No,
that might
no,
take a
it's
while. But
yeah.
I have used this to upload to Aura for a couple of test things. It uploads to desktop. We also have both. We've uploaded both community and enterprise editions of Neo4j. So as far as I'm aware, it connects to pretty much every platform Neo4j offers.
Okay. Well, that sounds good. So I mean, basically, you need when you show the here, you need to type in the connection at the beginning, and then you just type in the URL and then a username and password, and from there, you get from Aura, you get a URL. You from obviously from desktop you get one, but from your server you get another one, and then you just type it in there and connect it.
And this would be the HTTP or HTTPS endpoint.
Yeah.
The tool behind the scenes uses the metadata it gets from that endpoint to identify the bolt URL, which is what it actually makes the connection with. But you don't want to put the bolt URL right into here, because then it won't be able to find what it needs.
Okay. So HTTP URL is needed, but that's obviously published, so you can use that.
Yep.
Cool, that's very good. Yeah, I mean, maybe if people are now trying this out and are the links are in the description. If anybody has any feedback, I guess you'd be the one to talk to and to reach out to. What's your preferred way of people contacting you if they come to be any feedback, any, I don't know.
Yeah. There's a couple different ways. I would share my T Larsen data guy email, which can be used. I think I'll share it. So that's one way. Email is usually easy for people. I'm also on Twitter and LinkedIn if you want to shoot me a tweet or a message. You can also submit an issue on the GitHub repository if you think you find a bug or something. Like one issue I just discovered a couple days ago is the input tool doesn't graciously handle optional matches. If there's a null node, it kind of errors out. So things like that, that weird stuff, throw it into an issue if that's how you like to interact. GitHub's a great way to collect some of that information.
Absolutely.
If someone emails me or messages me, I'll probably put an issue in the GitHub repository anyway. So that's like the most direct route to go.
Okay. Great. I mean, that was very exciting, very interesting, cool tool. And thanks for showing us, but thanks for programming it and developing it. So I hope lots of Alteryx users are now happy and can connect a Neo4j database to their Alteryx streams, and vice versa, and then work alongside with the two tools. That would be nice to see, I guess, and yeah, good good to have. So yeah, thank you very much, Tom, again for spending the time and showcasing your Graphyx connector. Thank you for watching, everybody. I think this is the end. Any final comments? Anything you wanted to add, Tom?
No, at this point, thanks, Alexander, for having me. I really appreciate it. It's been a blast, and I'm trying to push Neo4j in the Alteryx community. I think it's a fantastic platform, and I think now Alteryx works well with it, and I think those tools can coexist very well as we demonstrate in my team. So, would love to see more uptake on the Alteryx side. Graph is just such a nice way to think about data. I love it.
Yeah. Especially now that you say that, I mean, Alteryx is a very visual tool. Neo4j is a very visual tool. So I think by design, the two would make a lot of sense to work together especially for people who are in a no to low code environment, where working with Bloom on the one side for a graph visualization, working with Alteryx on the other side, connecting the two is a great way to do things without having to write queries or other hard stuff if you're not a hardcore developer per se.
Absolutely.
Yeah. All right, cool. Again, Tom, thank you very much. Everybody, thank you for watching. This was it. Take care, everybody. Have a good rest of your week, and I'll see you soon with another Neo4j live stream. Bye-bye.
Bye-bye.